So just a quick recap, since I barely started recording. We're doing MVT for integrals. Our goal is to find the average value, and the difference between mean value theorem for derivatives and mean value theorem for integrals is that we're comparing the average rate of change in mean value theorem for derivatives, whereas mean value theorem for integrals, we're finding the average value. So let's say I had a function just a random function. When we talk about temperatures, this would probably not be the best one for temperatures. I just made up a random one. And we want to find an average value. So when we're talking average value, when we're talking about values, we're talking about the y values. The x-axis is usually time. So it's usually where we're taking our measurement. But value, we're trying to find an approximate average y value. So I want someone to come up and draw a straight line where they think approximately our average value would be at for this picture. Yeah. Ben will come up and do it. So a straight horizontal line from 0 to that end asymptote I put there.
I like it. No,
So where you think approximately the average value would be. Horizontal line. Can't be tilted. Horizontal. Okay? Does that look feasible? Our lowest is like here on the left, so negative. I didn't even attempt to knock it down that time, so it was not my fault. Our lowest is like -5. Our highest is like 10. So is that line about halfway between the lowest and highest?
Just say
Approximately.
yes.
We might maybe put it a little lower since we have so many more lower values than higher values here. Okay. So maybe even like that.
See how perfect that line was? Wow.
Okay, so we can find that average value. So just like average rate of change compared instantaneous, so this instantaneous slope to the average slope, so the slope of your tangent line to the slope of your secant line, we're going to be comparing two things like that, and graphically those are our areas. So what do we know integrals find for us?
Area underneath the curve.
Area underneath the curve. That's like our tangent line. We can find an exact area underneath the curve. I could find this exact area. Mathematically, if we're going from A, yes, that's 0 on my picture, but it doesn't have to be, to B. How would I write that out mathematically? What would my math equation be for that black area? And assuming my function.
From A to B of x.
The integral from A to B of f of x dx. So we're comparing that instantaneous area to the area we find with that average line. What kind of shape is that line going to give us? The horizontal line. A rectangle. So we're trying to compare our area in black to the area of this rectangle. So I can't find both with what I have written here, but I can find one side. What one side can I find right now? A to B. And what would the length of that side be? B. Assume that that A is not at 0. I should have put it B minus A. So this side is B minus A. So we know the instantaneous area would be B minus A times something, times some y value here. So we're going to call this y value f of c. And where our line crosses our function would be the x value c. So the area of our rectangle now would be b minus a times f of c. So we said that line was our average value, which means f of c right here is our average value. We drew that line specifically because we thought, well, it's about the middle of all those y values. If we took all of them, added them up, divided by how many there were, it'd be about in the middle. So if I want to actually find average value, what would I have to do to get average value alone?
Divide by b minus a.
Divide by b minus a. So that gives me my average value formula. Average value, f of c is given by 1 over b minus a, because we divided by b minus a, times the integral from a to b of f of x dx. So basically we take the entire area and we divide by the interval we took that area over. Which also kind of makes me feel averages. You know, when you do averages, you take so many things and add it together and then take how many you added together. This interval is kind of how many rectangles we've added together. So to me it makes sense in terms of that formula as well, because you're adding up a whole bunch of stuff and you're dividing by how much stuff you added together. Very weird form of it, but that's another way I kind of remember the average value formula. Did everyone have that down before I move on? Yes. Okay. So let's do an example. Suppose that C of t represents the daily cost of heating your house measured in dollars per day. And we are assuming t equals 0 corresponds to January 1st, 2008. Do you need to go get a drink?
I have water.
Find the average cost per day in the first 90 days if C of t equals 2x cubed minus 5x plus 20. They asked the question a little bit different in here, so I'm making up a function instead of using a function that they have carefully thought about. So
Oh dear.
and it'll still come out with a value, just hopefully the value will make some sense. We'll find out.
42,600,000.
So we're going to find the average cost per day. So now we just go to our average value formula. We know the average cost will be adding up all those costs per day and dividing by how many days it was. So it basically comes down to the average value formula. F of C equals 1 over B minus A. What is B minus A in this case? 90 is B minus 0. Why did we use 0 for A? Well, yes, it says T equals 0 corresponds to January 1st, 2008, but that's not actually what tells me to use 0 as A. The first 90 days. Okay. If I said the last 90 days of the year 2008, what would we use? That's a little bit harder. You have to know how many days are in a year. 365, so 275 to 365.
Yeah.
So we're going to do 90 minus 0.
Unless of course it's a leap year.
That's true. So we're considering just the first 90, which is why we use 0 to 90. So then what are my bounds on my integral? 90 and 0 again. They're the same. Because remember, an integral is just adding up a whole bunch of stuff. So we're adding up a whole bunch of stuff with the integral and then dividing by how much stuff we added together. And then we use our function. So then go ahead and just plug this one into a calculator. We've done a lot of practice with anti-power rule.
So wouldn't
So
you,
just plug this entire thing into your calculator.
to do that, wouldn't you put the 90 in for the x's and then minus that from 0?
You have to do something before you do that. What do you have to do before you plug 90?
Oh, you have to find the antiderivative of that.
Yes, find the antiderivative first, then
So x
plug
to
in
the
90.
fourth would be 1/2 x
Yep.
to the fourth minus 5/2 x squared plus 20x.
Yep.